Alright, let's tackle chapter problem 4. Two rival PE firms are interested in finding the same two startups. Each would prefer not to get into a bidding war with the other regarding either of the startups. Payoff are given in the following table. What are the reservation prices for managers at the two firms? So here reservation prices, nothing but the payoff, right? Because we do not have any other numbers. So you can simply think that as payoff for manager at the two firms. What will bidding look like? So it asks you to predict the strategy of each firm and the outcome of payoff. Let me see you on the whiteboard. Let's first check whether each firm has a dominant strategy. So for firm B, the payoff is from investing company 1, either 10 or 60 depending on opponents. Invest 2 option generate 25 or 20, right? So you're comparing these two, and the inequality is 25 greater than 10, but 60 is greater than 20. So investment schedule 1 or 2 can be generating greater payoff depending on invest of other opponents, right? So there's no dominant strategy as none of the strategy generate always greatest payoff. As you see, the inequality changes the direction, right? No dominant strategy for company B. What about company A? So investment 1 generate 10 or 55 depending on company B's reaction. Investment plan 2 generate 40 or 20. So if company B opponent respond by invest 1, company A's investing 1 generate less payoff compared to investment 2. But then it can be actually generate better payoff if the opponent play different strategy. So as you see here, inequality, the direction changes, right? When you compare these two payoff factor for column player A. So again, the conclusion is company A does not have dominant strategy either, right? No dominant strategy. So there's no dominant strategy equilibrium. Now we can see whether we can find Nash equilibrium for this example. Now let's see whether we can find Nash equilibrium, right? So company B, for example, if we plan to do invest 1, of course, opponent firm A can anticipate that possible strategy, right? So with that anticipation, firm B playing invest 1, company A will respond by comparing the two strategy that generate 10 or 40. So if company A expect company B will do invest 1, company A will respond by choosing invest 2 because it generates greatest payoff to company B's strategy invest 1, right? So we can say firm A's invest 2 is a best response or best reaction to firm B's invest 1. What about if the company B does different strategy invest 2? If company A expect company B will do invest 2, then choosing invest 1 will generate 55. Choosing invest 2 will generate 20. So company A will respond to company B's invest 2 by choosing invest 1, right? So company A's reaction we just figure out, right? What about company B? If company B think that company A will do invest 1, company B can receive 10 by doing invest 1 or 25 by invest 2. So company B's best response to company A's investing 1 will be choosing invest 2. But then if company B think that company A will do actually invest 2, investing 1 will generate 60 while invest 2 only generate 20. So you can say company B's investing 1 is the best reaction to company A's invest 2, right? So what happened? We end up circling two numbers in the same cell, and there are two locations here, right? Two combination of each strategy of each player, and two circles ended up in the same cell. So this game has actually two Nash equilibria, multiple Nash equilibria. That is stable from each player's deviation as long as all other players maintain that Nash equilibrium strategy. So as a summary, we can say, okay, company B, if it is deciding to invest 2, and as long as company A, opponent, does invest plan 1, as long as this is maintained, company B does not see any reason to deviate alone to investment 1, right? As long as opponent does Nash equilibrium strategy. And same thing, if company A think that by choosing invest 1, it can generate 55 and opponents maintain Nash equilibrium strategy. If opponent maintain Nash equilibrium strategy, company A does not see the reason to deviate other strategy as it only reduces the payoff. So Nash equilibrium guarantees stable payoff as long as opponents keep playing Nash equilibrium strategy so that unilateral deviation from Nash equilibrium does not increase the payoff. You can also apply the same logic to check firm B invest plan 1, firm A invest plan 2 is another Nash equilibrium strategy. So you can say there are 2 Nash equilibria, which is company A does invest 1, company B does invest 2. That's one Nash equilibrium. Another one is company A does invest 2, company B does invest 1, right? So there are 2 Nash equilibrium, which is the strategy that generate best reaction to opponent's Nash equilibrium strategy. Thanks for watching.